Here's something I see quite a bit. A developer builds a beautiful backend API. Tests pass. Everything works perfectly. Then they build a front-end component. Tests pass there too. But when they connect the two, complete disaster. The data doesn't match, the states don't sync, and suddenly they're debugging across 15 files trying to figure out where it all went wrong. Sound familiar? It doesn't have to be this way. In this lesson, I'm going to show you how to build full-stack features the professional way. Not one giant leap of faith, but 3 small validated steps. Backend, front-end, integration. Each one proven to work before you move to the next. By the end of this video, you'll have a pattern that lets you build any feature at any scale with complete confidence. Until now, we've explored piv loops in isolation. Backend piv loops that create endpoints and validate them with tests. Front-end piv loops that build components and verify them visually. Each loop was contained within a single lane, a single layer of the stack. That isolation was intentional. You learned the discipline of small, focused changes before attempting anything larger. But real features don't live in just one layer. Real features span the entire stack. Today, we connect everything. We build a complete feature, from database to user interface, using multiple coordinated piv loops. The feature we'll build is product search. Users type a query. The front end sends it to the backend. The backend searches the database, and results flow back to display on screen. This is not a complex feature. That's the point. Complex features are just simple features stacked together. If you can build one full-stack feature with disciplined piv loops, you can build 100. The pattern doesn't change. The complexity just layers. Master the pattern once, and scaling becomes a matter of repetition, not reinvention. Here's the critical insight that separates professional development from chaos. Full-stack features are not built in one giant piv loop. They're built in multiple small piv loops, each focused on one layer. Piv 1 handles the backend. Create the endpoint, write the tests, validate everything works in isolation. Piv 2 handles the front end. Build the UI, connect it to the API, verify the component renders correctly. Piv 3, which is optional but valuable, adds end-to-end tests that verify the entire flow works together. 3 loops, 3 validation checkpoints, 1 reliable feature. Why not build everything at once? Why not write the endpoint and the component and the integration in one massive session? Because when something breaks, and something always breaks, you won't know where to look. Was it the database query, the API response format, the front-end state management, the component rendering? When you build incrementally with validation at each step, the broken piece is always in the most recent loop. You never debug the entire stack. You debug the last change you made. That's why lane-specific piv loops matter even more in full-stack work. Let's begin with PIV1, the backend loop. Our goal is simple. Create a search endpoint at products/search that accepts a query parameter and returns matching products. This endpoint needs to handle several cases. When the query matches multiple products, return all matches. When the query matches nothing, return an empty list. When the query is too short, return an error. Each case needs a test. The endpoint doesn't exist until the tests prove it works. Here is the structured prompt that defines our backend piv. First, context. We tell the AI we're working in a fast API backend with vertical slice architecture. The feature belongs in features/products. Database is Postgres with SQL Alchemy. Tests use PyTest. Second, the task. Add a get endpoint at products/search with a query parameter. Match by substring on product name, case insensitive. Return the same response schema as the existing list products endpoint. Third, constraints. Only edit files under features/products. Follow existing patterns for router, service, and repository. Add 3 specific tests. Fourth, validation. List all files changed. Run PyTest on the products feature. Notice what this prompt does not do. It does not ask for architectural decisions. It does not invite creativity about response formats. It does not leave room for the AI to improve the codebase while it's at it. The prompt is surgical. One endpoint, one feature directory, 3 tests, existing patterns. When you give AI this level of specificity, you don't get surprises. You get exactly what you asked for, which means you can validate exactly what you expected. The AI generates the search endpoint. In the repository layer, it adds a search method that uses SQL Alchemy's I-like operator for case-insensitive substring matching. In the service layer, it validates the query length and calls the repository. In the router, it adds the get endpoint that extracts the query parameter and returns the response. The pattern matches what already exists in the codebase. New capability, familiar structure. This is what happens when you constrain AI to existing patterns. It extends the system instead of reinventing it. Now validation. We run PyTest on the products feature. 3 tests execute. Test 1 confirms that searching for widget returns products containing that substring. Test 2 confirms that searching for a non-existent term returns an empty list. Test 3 confirms that searching with a single character returns a 400 error. All 3 pass. The endpoint works. But we're not done. We check the types with MyPy. We run the linter. We verify that no other files were modified. Only when all validation passes do we close this piv loop. What have we achieved? A working, tested search endpoint. A backend feature that exists independently of any frontend. An artifact we can deploy, document, and maintain separately. This is the power of lane-specific piv loops. The backend search works whether or not we ever build a frontend for it. It's complete in itself. Another team could consume this API. Another project could reuse this pattern. The feature has value even in isolation. Now we move to Piv 2, where we build the interface that humans will actually use. Piv 2 focuses entirely on the front end. Our goal is to create a search component that lets users type a query and see matching products. This component needs a text input, a submit mechanism, a loading state while the API responds, an error state if something goes wrong, and a results display. Each of these elements needs to work correctly before we consider this piv complete. The front end has its own validation layer, and we respect it. Here is the front-end piv prompt. Context tells the AI we're in a React TypeScript front-end with vertical slice architecture. The feature belongs in Features Products. We use React Query for data fetching. Tests use Vitest and React Testing Library. Task is to create a product search component with an input field, search button, and results display. Use the existing API layer pattern. Handle loading, error, and empty states. Constraints specify that we only edit files under Features Products, follow existing component patterns, create a custom hook for the search API call, and add tests for each UI state. Validation requires listing all files changed and running Vitest on the products feature. The AI generates the front-end feature. First, it adds a search function to the API layer that calls our backend endpoint. Second, it creates a custom hook called useProductSearch that wraps React Query's useMutation. Why mutation instead of query? Because search is triggered by user action, not component mount. The hook manages loading state, error state, and the results. Third, it builds the product search component, a form with an input and button, conditional rendering for loading, error, and results. The component knows nothing about fetch logic. It just uses the hook and renders based on state. The tests verify each state. Test 1 confirms the component renders an input and search button. Test 2 confirms that submitting triggers the search function. Test 3 confirms the loading state appears while waiting for results. Test 4 confirms the error state displays when the API fails. Test 5 confirms the results render when data returns. Each test isolates one behavior. When any test fails, you know exactly which behavior broke. This is the same discipline we applied to the backend, now expressed in front-end terms. We run vytest. All 5 tests pass. The component works in isolation, independent of whether the backend is running. This matters because front-end and back-end developers often work in parallel. Your front-end tests shouldn't require a live server. They mock the API responses and verify that the component handles each case correctly. The real integration happens in the browser, or in end-to-end tests, not in unit tests. Keep your test layers separate. Let each layer validate its own responsibilities. What have we achieved? A working search interface that handles loading, error, and success states correctly. A component that follows existing patterns and fits into the feature architecture. A suite of tests that catch regressions automatically. 2 complete piv loops, backend and frontend, each validated independently. The feature is almost ready, but there's one more level of confidence we can add. An end-to-end test that proves the full flow works together in a real browser. PIV3 is optional but powerful. End-to-end tests use tools like Playwright or Cypress to automate a real browser. They simulate what an actual user would do. Type into the search box, click the button, wait for results to appear, verify the correct product's display. Unlike unit tests that mock dependencies, E2E tests run against the real system. The real front-end talks to the real backend, which queries the real database. This is the ultimate validation that everything works together. Here is the E2E piv prompt. Context specifies we're using Playwright for end-to-end testing with the full stack running locally. Task is to write a test that navigates to the products page, enters a search query, submits the search, and verifies that matching products appear. Constraints limit us to one test file in the E2E directory, using existing page object patterns if they exist. Validation requires running the E2E test suite and reporting pass or fail. Notice we're not asking for comprehensive coverage here. One test that proves the full flow works. The AI generates a Playwright test. It navigates to the products page. It locates the search input and types a query. It clicks the search button. It waits for the network request to complete. It verifies that the results contain the expected product names. The test runs in about 3 seconds. It exercises the entire stack, from browser to database and back. When this test passes, you have high confidence that the feature works, as users will experience it. When it fails, you know the integration is broken somewhere. End-to-end tests are expensive. They're slower than unit tests. They're more fragile because they depend on the entire system being healthy. They require real infrastructure. This is why we don't start with E2E tests. We start with unit tests in each layer. Those fast, isolated tests catch most bugs. E2E tests are the final verification layer, the proof that everything connects correctly. Use them strategically, 1 or 2 tests per critical user flow. Don't try to test every edge case at the E2E level. That's what unit tests are for. Let's step back and see the complete pattern. Piv1 builds and validates the backend in isolation. The endpoint works, the tests pass, the types check, the layer is complete. Piv2 builds and validates the frontend in isolation. The component works, the tests pass, the states render correctly, the layer is complete. Piv3 validates the integration. The E2E test proves the full flow works. The feature is production ready. 3 piv loops, each focused on one concern, each validated before moving forward. This is how professional teams build full-stack features with AI assistance. The key insight is that complexity is managed through decomposition. A full-stack feature feels complex because it spans multiple layers, technologies, and concerns. But when you decompose it into lane-specific piv loops, each individual loop is simple. The backend loop is just another endpoint. The frontend loop is just another component. The E2E loop is just another test. You already know how to do each of these in isolation. Full-stack work is just doing them in sequence with validation between each step. What happens when something breaks? This is where the pattern proves its value. If piv1 passes, but piv2 fails, the bug is in the front end. You don't debug the back end. If both layer tests pass, but E2E fails, the bug is in the integration. Check API contracts, check data formats, check network configuration. The validation checkpoints narrow the search space. You're never hunting through the entire stack. You're always investigating the most recent change in the most recent layer. That's the debugging superpower that piv discipline provides. This lesson completes the PIV loop foundation. You now have the pattern for building any feature at any scale, across any number of layers. Backend PIV, front-end PIV, E2E PIV. Small, validated, complete. In the next lesson, we'll explore how this architecture enables safe refactoring and parallel work with AI. Multiple developers and multiple AI agents working on different features simultaneously without stepping on each other. The vertical slice architecture and PIV discipline make that possible. Until then, practice this pattern. Build a feature, validate each layer, experience the confidence that comes from knowing exactly what works and why. All right, let's bring it all together. You just learned the pattern that professional teams use to build full-stack features without losing their minds. 3 piv loops, 3 validation checkpoints, 0 guesswork about where bugs live. First, the backend piv. Build your endpoint, write your tests, validate it works in complete isolation. Second, the front-end piv. Build your component, mock the API, prove every state renders correctly. Third, the E2E piv. Connect everything, automate a real browser, verify the full flow works as users will experience it. The magic isn't in any single step. It's in the validation gates between them. When something breaks, you know exactly which layer failed. You're not hunting through the entire stack. You're investigating the last thing you changed. That's the difference between debugging for hours and debugging for minutes. Now here's what I want you to do. If this pattern clicked for you, hit that subscribe button. The next lesson covers safe refactoring and parallel work with AI. And trust me, you don't want to miss how this architecture lets multiple AI agents work on your code base simultaneously without conflicts. Also, smash that like button. It tells the algorithm that this kind of deep, practical AI content is valuable, and it helps more developers find it. And hit the notification bell so you know the moment the next lesson drops. Go practice this pattern, build something, validate each layer, and I'll see you in the next one.